Okay, so what we're going to do is look at a typical problem in business calculus, looking at cost, revenue, profit type ideas. So what we have here is the cost of producing X units can be modeled by this function right here. The selling price per item can be modeled by this function right here. And keep in mind, this is selling price, so this isn't revenue or profit or cost. So we have to do something with that information probably. And the big question of the hour is, what is the maximum profit based on this setup? So remember that the first thing is that profit, capital P, is equal to revenue minus cost. And the missing piece here is that we don't have revenue. But remember also that revenue is equal to quantity times price. So X is the quantity and the price is 40e to the negative 0.01x. So we just usually write that as 40x times e to the negative 0.01x. So there's our revenue. Okay, so that's R of X if you want to call it that. Okay, so then profit, or we like to call P of X, is the revenue function 40x e to the negative 0.01x minus the cost function. Now, if the cost function is all of this, we have to make sure we subtract it all, so I'm using parentheses here. And now what we should do, since we're going to be doing calculus with this, is we should try to simplify this if we can. So naturally the first term stays the same, but notice that we can distribute a negative over there. So you get minus 100 minus 20x e to the negative 0.01x. And sure enough, we can combine this, and that gives me 20x e to the negative 0.01x minus 100. So that's my profit. So remember that one idea is that if you want to find the maximum profit, you have to find the place where the first derivative of the profit is equal to 0. So right now, what we're going to do is take the derivative of this, and just to remind ourselves here, we're trying to differentiate an expression that has 20x here and e to the negative 0.01x there. That's a product rule. So in order to differentiate a product, we need to know the derivative of each factor, and remember that it's kind of a crisscross kind of idea that gives us the derivative of the product. So I'm just going to erase that and move that later. So the derivative of the first piece, which I'm just going to call 20x, is 20. And the derivative of the next piece, well, remember that the derivative of e to the something is e to the something times the derivative of the something. And I'm just going to leave it that way for now. So if I want P prime of X, which remember in business calculus world we call the marginal profit, well, that's going to be, so it's the derivative of the first times the second plus the first expression times the derivative of the second expression. And of course, we should simplify that. So we have 20e to the negative 0.01x. Now we can multiply the 20 and the negative 0.01, and that gives us negative 0.2x e to the negative 0.01x. And we know that what we want to happen occurs when the derivative is equal to 0. That's how we locate all min and maxes. So we still have a little bit of ways to go yet. We have to find the critical number, and then we then have to verify, at least we should. We know it probably is going to be, but we need to verify that it is indeed a maximum. So copying this to the next page, we're going to have, so you have 20x e, no, that was 20, right? 20e to the negative 0.01x minus 0.2x e to the negative 0.01x equals 0. So luck would have it, we can actually remove a common factor. We should factor whenever we can, especially if it's set equal to 0. So I'm going to factor out the e to the negative 0.01x, and that's going to leave me with 20 minus 0.2x in parentheses. Now the zero product property tells us, well, if you have a product of things that are equal to 0, that means that each thing could be equal to 0. So I'm going to temporarily say this. And one thing to realize here is that you have an exponential, and an exponential function can never be equal to 0. Plug in anything you want to in the exponent. You're never going to get 0, so this is impossible. But luckily, the right-hand equation is pretty easy to solve. It's just a linear equation. So I'm going to add 0.2x to both sides, and I'm going to divide both sides by 0.2. And that gives us x equals 100. So at a quantity of 100, our profit is maximized. So I'm going to label that here. That's pretty important. So this helps the people in the budget department, how many items should I make if my goal was to maximize profit? Make too many and we're not going to sell them all. Don't make enough, and well, that means we have to price them too high. So this is kind of the balance. So now we have to verify that it's a maximum. And there's a lot of ways we could do that. We could take a second derivative, and given that we have a product rule ahead of us, I don't think we want to do that. We're just going to use the first derivative test looking at the sine graph. So we have our sine graph here, and 100 is the point that we have to test. So we're going to plug something in to the left of 100. What better number to use than 0? And something to the right of 100, we could use 101. I'm just going to pick 200 because it's 100 units away. So if we find the marginal profit at 0, and if we find the marginal profit at 200, well, let's look back at our marginal profit function. That was this right here, right? So, or we could use the factored form, which might be a little bit easier to use. So if I plug in 0, I get e to the 0, which we know is 1, times 20 minus 0, and that gives us 20, which is positive, which means to the left of 100, where x equals 0, and every value left of 100, I know my profit function is increasing. Okay? So then if I plug in 200, I get e to the negative 0.01 times 200 times the quantity 20 minus 0.2 times 200. Now, if we calculate this out, now let's just think about this. This inside parentheses actually tells a story. This is 20 minus 40, which is a negative 20. And this quantity right here is positive. So that means that whole thing is negative. I urge you to check that with a calculator just to double check. But that does tell us that it is decreasing at 200, which means it's decreasing to the right of 100. And that also means, guess what? We have a maximum profit at 100 units. So that's wonderful news, okay? Now, just going to get rid of this real quick here. So now let's answer a couple other questions here. What is the max profit? We got the number of units that makes it happen. What is the max profit? Well, we know that P of x was 20x e to the negative 0.01x minus 100. So that means the max profit happens when x is 100. So it's 20 times 100 times e to the negative 0.01 times 100 minus 100. Now, we can compute this out as much as we can before we go to a calculator. This is 2,000 e to the negative 1 minus 100. And if we pull out a calculator, we will get 2,000 e to the negative 1, not times, minus 100. And that tells us we're going to make a profit of about $636. So I am going to just say 636. Another thing we can do is we can find the price per item. That's information that people would want to know, right? Well, we know that the price function was P equals, And let's just go back to our original function here, original page here. It was 40e to the negative 0.01x. So at x equals 100, the price is 40e to the negative 0.01 times 100, which is 40e to the negative first. And again, go into my calculator. 40e to the negative first is $14.72. So whatever we're selling here, that is going to be the price of the item when profit is maximum. So I hope that helps us to pull some things together, even though my book here is going a little bit wacky here. But I hope that helps you pull some things together, and I thank you so much for watching.